Thank you very much for joining us. And I welcome you again if you're a returning person to another one of our webinars as part of the EMC. And then if you're a new person, welcome to join us today. It's a little bit of a different topic to what we've had previously. So far we've had 3 events covering the EMC and what that means, the new user interface that we use for OSeMOSYS, and then also a women in modeling focused discussion. But today this is focusing more on osmosis itself and a sort of application of it around wave technologies, which I certainly won't go into detail. I'll leave that to Esteban. But just to introduce the other 2 faces you may see on your screen now. So we have Fernando Plazas, who is the osmosis model curator at CCG. And he has been with us for a few years now since being part of one of our EMP events. So I'll let him speak next to introduce himself and just maybe briefly introduce osmosis. Then we also have Esteban, who is an economist and oceanographer with more than 10 years experience in data analysis, climate data, and ocean circulation models. And he has experience in the development of sustainable bioeconomy projects and long-term energy planning, and is committed to promoting biodiversity, conservation, and sustainable development. So some really important work, and I'm sure something that everyone will be really interested to see. So just for everyone's knowledge, if you're listening live or if you're listening to the recording on YouTube, once we'll have the presentation from Esteban, then we'll have a sort of plenty of time for question and answer. So please, throughout this discussion, please use the chat and the Q&A, and we'll moderate the questions, and then at the end we can sort of have time for question and answer. So if you do have any questions, use the chat or Q&A, or keep them for the end. So yeah, it's great to have everybody with us. So I'll pass over to Fernando, and then we'll pass over to Esteban. Thank you.
Good, perfect. Thank you, Kane, for that kind introduction. Just as Kane was saying, my name is Fernando Plazas. Currently, I'm working as a research consultant for CCG, and I'm in charge of the model curation for osmosis. I think that because I see many familiar colleagues joining us today, just to say that maybe for most of you it's quite very known what osmosis is just to say that from a mathematical perspective, let's remember that osmosis is a optimization model which is minimizing unobjective functions, which is basically the total discounted cost of the energy system. And in practical terms, we can say that osmosis is just an integrated energy system framework that is very useful for energy planning in the long term, especially. And maybe if you review some of the research that probably you can find online, or also if you are more interested, we can talk about this maybe at the end of this talk. You will find that osmosis is mostly used for capacity expansion analysis of the power sector, but it is also useful for other kind of analysis, like for example, transport planning, also regional integration. Also, we have what we call cost-benefit analysis, and obviously we can analyze other strategies, like for example, sector coupling, when we are doing this integrated analysis where it is possible not to just represent the power sector, but also the end-use sector, like for example, transport, residential, industry. So as you can see, osmosis is a very good tool for energy planning. It's possible to do many kinds of analysis, and obviously that if you are more interested in this topic, we are totally keen on supporting you on everything that you are interested in. So yeah, that would be like my introduction, and thank you once again for joining us, and over to you, Kane.
Thank you very much, Fernando. I am aware actually that maybe I didn't introduce myself. I just assumed that everyone would know who I am. But I am Kane Alexander, currently the CLEWs model curator, similar to Fernando for osmosis, and also the person in charge of the energy modeling community at CCG. So most of these webinars, you're probably going to see my face at least introducing them or around. So it's nice to see familiar faces, and it's nice to see some new ones again. So I'll hand over to Esteban now. Thank you very much.
Hello, everyone. I'm Esteban Meneses from Quito, Ecuador. I'm going to share my screen. Well, I'm going to talk about a little bit of our work that we made with a group of professors of the San Francisco University of Quito. It's about the potential of wave energy converters in the Galapagos Island. Well, as reference sources systems, we have that the primary sources are waves, wind, solar, and diesel. This diesel is imported diesel from Ecuador mainland. So we have 5 technologies: thermal power plants with internal combustion engines, solar distributed energy, solar photovoltaic centralized energy, wind energy, and wave energy converters. We have some storage capacity, and the final energy goes for residential, shops and services, and land transport, electric land transport. As an introduction, I have that population, tourism, energy demand, and gross added value all have a exponential growing trend over the past decades. We consider the 4 inhabited islands: Santa Cruz, San Cristobal, Isabela, and Floriana. Santa Cruz has half of the population and half of the energy capacity, which is around 18 megawatts. And the tourism in this island is around 8 times greater than the population. So therefore, is a tourist-based economy, the Galapagos Islands. For the generation of electricity, we have that the thermal power plants covers around 84% of the electricity generation. Next comes the wind power plants with around 12%. And then comes the centralized solar photovoltaic power plants that reaches only 4% of the generation. As a methodology, we use the data we use was 2 seasons, the rainy one and the dry one. We took into account the 4 populated islands. The time span is from 2019 to 2050. And we use 2 modes of operation due to the batteries that give and store energy. And for the natural resources, we took the typical meteorological year that covers around 14 years of data. The solar data was taken from the National Renewable Energy Laboratory, this SAM application. The wind data, we took it from the Ninja Wind app that comes from the NASA MERA satellite data. And the waves data, we took it from the GLOSWAP platform, which is a platform for spectrum wave data and a wind sea data. We took a top-down approach where the theoretical and the gross potential of wave energy converters take into account the natural and climate factors, physical restrictions, energy content of resources, among others. The sustainable potential covers the environmental aspects, species distributions, sustainability factors, among others. And the techno-economic potential that covers cost projections by technology, cost projections by fuel, economical constraint, technical limitations of the technology, and systems performance. As gross wave energy potential of wave energy converters, we took 40 years of data, and we can see in this map that the wave power is concentrated in extratropical areas, both in north and south. But in these areas, in winter, they have enormous amount of wave energy. So the resilience of the wave energy converters got compromised. By contrast, here in the tropical areas where the Galapagos Islands are, we have a significant wave energy throughout the year with no extreme conditions in winter. So to get the gross energy potential, we consider the whole perimeter of the Galapagos Marine Reserve, which is this fictional line here. And if we could harvest all the wave energy that comes to this perimeter with the wave energy converter considered here in this work, we could have a potential of 30 gigawatts in terms of capacity, or over 200 terawatts a year in terms of generation. As sustainable wave energy potential, we know that the islands are an ecologically rich archipelago that was declared as an heritage site by UNESCO in the 80s. These ecosystems has high levels of endemisms, species, so it's very important for conservation. When we talk about the potential impacts of wave energy converters on ecosystems and tourist activities, because these islands are tourist-based economy, we, for instance, could say that WECs could be visually intrusive, especially offshore. WECs could also generate chemical and noise pollutions, and WECs could also alter maritime habitats. And considering all high ecological value areas, this author, Escobar Camacho, identified that 2.7% of the Galapagos Marine Reserve, which is those areas in red around the coast of the islands, has high levels of sensitivity in their ecosystems. So we consider only 1% of the Galapagos Marine Reserve, and the potential of wave energy converters remains substantial, with these wave energy converters with a capacity of 2.9 gigawatts. And when we talk about the techno-economic wave energy potential, we have that the main barriers here is that wave energy converters systems are still under development. The key variables like layering rate, capacity factors, energy conversion efficiency vary greatly among different types of WECs and designs. There's also lack of previous experience here in the Galapagos Islands and in Ecuador. And the variables considered here was a 5% of layering rate every year, an average capacity factor of 22%, and 49 energy conversion efficiency. And the WEC proposed here was taken from Guachamin and his peers' design, which is a vessel with two arms of conical shapes that track water up and down, take into advantage the roll-on and the hip movement of the vessel. Well, for long-term planning, as you may know, we use the open source modeling system, OSeMOSYS, which is a model that optimizes by minimum cost, taking into account the efficiency of the technologies, capacity factors based on the resources profiles, operational life of the power plants, current energy infrastructure, among others. The cost of the technologies, for instance, in terms of the investment costs of the wave energy converters, we start up in 2019 with around $8,000 per kilowatt, and we end up in 2050 with around $4,400. All costs, investment costs, operational management, fixed and variable, all have a decreasing trend over the years, with the exception of the thermal power plants. For instance, here, the wave energy converter technology has an operational lifespan of 25 years, and we have that the levelized cost of electricity starts up in 2019 with around 52 cents and ends up in 2050 with around 27 cents per kilowatt hour. We also considered the fuel prices with and without subsidies. Here in Ecuador, we have a great amount of fuel subsidies. And the fuel prices without subsidies considered the transport and storage from Ecuador mainland to the Galapagos Islands, which is around 35% according to the government. For the wave profile and wave systems, we consider the three main wave systems, this is a spectral plot where these two wave systems comes from the north, and this comes from the south, from the Antarctica. And the highest activities are in May and June. That's how we build the wave profile, the wave energy profile. For scenarios, we considered 4 scenarios. The referential scenario where thermal energy predominates with no major investment in renewables. The solar and wind future with heavy investment in solar and wind energy. And the wave, wind, and solar scenario with heavy investments in wave, wind, and solar energy, reaching 100% of clean energy up to 2040. And the electric transport scenario that comes from the previous scenario, but with additional electric expansion to cover electric transport. As a result, we have that the investment cost between the referential scenario and the scenario with WEX, we can see that in all technologies, with exception in thermal power plants, the scenario with WEX is more expensive than the referential scenario. We use a discount rate of 10%, and all dollars are in 2021 dollars. At the end of the period in 2050, we have that the WEC scenario is around $60 million more expensive than the referential scenario in terms of investment costs. For the operational management and fuel costs between the referential scenario and the scenario with WEX, we also can see that in almost all technologies, the scenario with WEX is more expensive than the referential scenario, with the exception of the thermal power plants. But when we talk about the fuel prices, the fuel cost, we have that the referential scenario is way more expensive than the scenario with WEX. This is due to the upgoing trend of the fuel prices that we considered. In terms of energy capacity, between the referential scenario and the scenario with WEX, we can see that at the end, in 2050, half of the capacity comes from the thermal power plants, and the other half comes from solar and wind energy, but mostly solar. On the other hand, on the scenario with WEX, we have that at the end of 2050, we have an installed capacity of 20 megawatts, and the rest comes from solar power plants. As you know, the OSeMOSYS model optimizes by minimum cost. So we had to force the model to install wave energy capacity over the years. In terms of mean electricity costs between the referential in the WEC scenario, in all populated islands in the Galapagos, we had that in 2019 we start up with around 23 cents per kilowatt hour, and we end up with around 17 cents per kilowatt hour. We have the similar trend over the 4 populated islands. And as a conclusion, we have that the Galapagos Islands have high wave energy potential. However, the wave device used here is currently less competitive than proven renewables technologies like solar and wind energy. So it's feasible to change the power sector in the Galapagos with just solar and wind, but you have to consider it that the land in the Galapagos are very limited because it's a national park, basically. In addition, WECs are not really needed in the islands. However, incorporating diverse renewables can ensure long-term energy resilience in the islands. But is it better for sustainability replace the current thermal power plants with renewables? Is it fair that this additional energy capacity is being used for endless growth of tourism on the islands? Those are just open questions to think about it. And the development of WECs will depend on global and local political willingness to improve these technologies to decrease, for instance, the prices and investment cost. And before start any project, is it crucial to make an environmental impact assessment first? That's it. Thanks.
Yeah, thank you very much, Esteban. A very interesting presentation, and very nice to hear quite a unique application of osmosis. I'm sure that many people will be very excited to hear about that, and also just to, it also outlines, the flexibility of osmosis and how you can sort of shape it to use it how you wish. So, if anybody has any questions, then now please use the chat and question and answer. If you have any questions, I have some questions actually, so maybe I can start with the two questions, and then if anybody else has any, then they can, follow on. I think so. One of my questions was more related to the research you did more generally, and it was just more of a query. In your opinion, do you think that wave technologies will actually become important to the Galapagos Islands, or more generally? Because obviously you said they might not be currently as cost effective, and maybe it's hard to change people's opinions. So I just wondered your opinion on that. And then secondly, I just wanted to hear about your experience using osmosis, and how you found actually using osmosis, and whether you plan to use it in future research. So hopefully they can be a good start for you.
Yes, thank for your questions. Right now, I think it's far from applying this technology in the Galapagos Islands because of the cost, basically, and there's also lack of the technology here. There's not a good technology to harvest the energy potential of waves. And for osmosis, I learned osmosis in one of those MPLAC courses on summer school. That was great for me because of that, I've been able of doing this work with my colleagues. So it's very friendly. I think for me it was very friendly to use and to learn, and it's open. Everybody can make improvements of that. That's for me that the better part of the model.
Oh, that's great. Thank you very much. Yeah, it's good to also have someone who's been trained with us at an EMP using the tool and able to, discuss their research, because that's, kind of what the EMC is about, bringing, the alumni back to do that. So really good to have you with us, and thank you for your answers. There's actually two questions in the chat. So one of them is, what was the lifespan for the wave technologies? I think someone maybe just wanted a refresher of how long the operational life of the wave technologies, and maybe how that is sort of calculated. I think maybe useful for some people.
Yes, we start to force the model in 2030 to install a very little capacity, because we had this wave energy converter design, that we have the energy conversion efficiency, we have the capacity, and then we just force the model to install every 5 years more capacity in the wave technology. And the lifespan of wave energy converters that we use was 25 years, the lifespan.
Okay, so 25 years, quite, I guess, similar to other renewable technologies then.
Yes, like for instance, wind energy or offshore wind energy. Yeah.
Cool. Yeah, very interesting. Thank you. So then the second question was, in your analysis, did you consider the cost of environmental impact?
Yeah, well, we just consider it as I told you, the species distribution. As I show you, the highly sensitive areas are around the coast of the islands. So we had to move the WEC device offshore, like not in the continental platform, and we considered that mainly.
Right. Oh, that Sounds really good. I think sort of maybe another question that sort of popped into my mind, and then maybe Fernando can go after me. Is there any do you have any plans for future research around this topic?
Yes, actually, I'm doing an addition research in this topic, including more electric land transport with more detail in this, specifically in land transport in the Galapagos.
Okay, great. No, that sounds really good. I'd love to hear about it in the future. I think we also have a participant with a hand up. So Haruna, please go
Yes.
ahead and speak.
Yeah, can you hear me?
Yes, we can hear you well.
Yes.
Okay, just want to ask some question regarding the investment side of wave technologies. Um, I don't know if you have included any political actors that can actually influence investment in the island. That's the first question. Like, in your research, have you considered the investment side of wave technologies and how we can actually bridge the gap to ensure that investment are coming in because of the potential of wave technologies? That's the first question. The second question is how do you, I mean, like, I just want to know if you have explored integration of hydrogen technologies or wave technologies. And yeah, these are the two questions I have. Thank you.
Thanks for your question. Well, we consider that there's all the political willingness in Ecuador and the Galapagos to make research and development of WEX, to improve this technology, to decrease the prices and everything. And for the second question, in the Galapagos, there's no water except with the exception of the ocean. So we consider all wave energy.
Great.
I
Thank
don't
you.
think it was clear.
No, I think that was clear. Yeah, thank you. And thank you, Haruna, for your question. Fernando, did you still have a question? There is two more in the Q&A. So maybe you go first, Fernando, and then I'll bring the next two questions in.
Sure. Yeah, just I want to say that thank you, Esteban, for the presentation. And I think it was a very good presentation because it was like just straight to the point and like the key messages were delivered in a very good way. So congratulations on that very good presentation. Yeah, I have two questions, maybe some small questions within each question, but the first question is about did you consider the integration between the different islands? Because as far as I understood, is like each island was one node, so the different nodes were not connected. So the first question is like, do you consider that kind of integration between the different islands could be something to be analyzed? That is the first question. And the second question is, how many time slices did you use for this analysis? And based on that, what is the role of batteries that you found in the study? Because I didn't see, let's say, the technology of battery or the storage in the different graphs. So I'm a little curious on what could be the role of that technology in this long-term planning. Yeah, that would be all. Thank you.
Thanks for your question, Fernando. Well, we consider it as you said, as isolated regions. Every island is an isolated region, so it's not interconnected because right now there's not the technology and the capacity are not the political willingness to connect this and to cover this interconnection. And for the time slices, we use 96 time slices. So we apply all our natural resources profiles to these 96 time slices. And I think I forgot one part of your last question.
Yeah, the role of batteries in the
The
analysis.
role of batteries. Because I made a quick presentation, I didn't put the role of batteries. But for instance, in the scenario with just solar and wind energy, the capacity of batteries is around 15 megawatts. So it's very important for the islands. It's very high at the end of 2050. So the batteries are very important in this model.
Great. Thank you, Esteban, and thank you, Fernando, for the question. So there's one more question in the question and answer, and it is, what made you choose a top-down approach for this energy modeling research?
Well, I think because the team that I am notice and they are working several years in the wave energy in these tropical areas, that there is a great amount and it's perfect for harvesting wave energy. So that's why I wanted to show you that there's high potential of wave energy, but the technological and economic constraints makes us that we can't use it yet, but maybe in the future, hopefully.
Thank you. Yes, go ahead, Fernando.
Yeah, sorry, just one extra question, Esteban. Is there any kind of stakeholder engagement for this study and the next steps that you would like to implement? I mean, it's like, maybe do you have any conversations with local government or maybe someone in the energy ministry to show the results and check how this could be used in the future for energy planning purposes? Is this kind of thing that maybe your university, your research group is trying to cover with the next steps?
Right now, we are trying to engage some activities just to show them that it's I don't know, it's a good solution. Maybe not for the Galapagos Islands, but maybe for Ecuadorian mainland. So right now it's just in the academic sector, but we want to show them in the near future.
Great. Yeah, thank you very much. Yeah, so before we close this webinar, are there any more questions from anybody? If there is, please use this time now. But if not, I think, Esteban, if it would be okay with you, someone be requested if they could have access to the slides, just so they could view
For sure.
it. Yeah, so maybe if you can either share them in the chat, I don't know if that's possible, or you can
Yes,
share them with me via email and I can attach them to the YouTube video. Or maybe I can do that also.
I have it in a link, so I can
Oh,
pass
great.
you over the chat.
Okay, yeah, that would be great. Yeah. So for everybody's reference, if you can see the chat, there should be a link shared. And I actually think we have maybe one more question from Haruna.
That's it.
It's not really a question. What's the YouTube channel that you are uploading
Perfect.
webinar?
Sorry, what was the question?
I said,
I
what
couldn't
is
hear
the
you. Sorry.
YouTube channel?
Sorry,
Like
Haruna,
you
go ahead.
said, you upload this event on YouTube. So I
Yes,
wanted
we
to
do.
like what's the name? What is the name of the channel?
Oh, okay. It's the channel is the Climate Compatible Growth channel.
Okay, CCG, right?
Yes, yes. So there is also a collection of webinars. So there's like a series that are all together, so you can watch the previous ones. And just for everybody's reference, Esteban has shared the link in the group chat, and I will also attach the link to the YouTube video once we post that as well. So yeah, thank you very much for that. So yeah, I think we can conclude there. Yes, very thank you very much, Esteban. It's great to have you with us and really hear about some of the interesting work you've been doing. And it's nice to have somebody who's learned at one of our EMPs. It shows that it's working. And yeah, it's great to have you with us, and hopefully see you again at another EMP or in future events. And yeah, so thank you to the people who joined as well. It's nice to see people, and hopefully people can join in the future for some more webinars. So yeah, thank you everyone. Have a nice day.
Thank you, Alexander. Thank you, Fernando, for inviting me. Hopefully see you soon.
Without a doubt. Thank you so much, Esteban. Have a great day for everyone.
Thank you, Fernando.
You too.
See you later, everybody.